Okay, so welcome everybody on my talk, Understanding Coupling. Couple of things about me. I'm as Szymon said before, programmer, architect, trainer, consultant, whatever. And my main line of work is helping other companies making software a little bit better. So like my experience is most companies are making okay software, and then we come, people from my company, and they are making it even better than they were doing it before. Yeah, so my my specialties are domain-driven design, architecture, continuous delivery things, but continuous delivery not from the infrastructure perspective, but also continuous delivery from architecture perspective. Yeah, in my private life, I have a wife, 5 kids, 3 sons, 2 daughters. So yeah. So you have to forgive me if I will not last till the end of the conference, because I also have to spend some time with them on Sunday. So hopefully it will be okay. Great. So let's start. Let's meet Guido. Guido Instinctive. This is Guido Instinctive. Who is Guido Instinctive? He's a Ruby, C#, some, let's say, object-oriented language or even functionally oriented language programmer. He was, sorry, I have a little cold, so also forgive me for this. He's just became a team lead at his company. He's starting to work his after a couple of years when he was just a programmer. Company trusted him, and he will become a team lead. And his main priority is good design. Yeah, he knows that he now will be responsible for this project, this team, this software that will come, and then this is his responsibility. Yeah, so he will be spreading the design knowledge to everybody, and he will be telling people how to do stuff and how to do it better, and he will be patient and all of this, and he will make this in this project, the design will be good. All the people will understand this design and will not argue with each other, why this, why that, and so on. And this is his new mission. Guido Instinctive. Okay. But when he starts this new project and this new role, he encounters a problem. What kind of problem he encounters? How to evaluate the design. So he goes to or sits with somebody on a code review. Somebody created some kind of software, and he has to somehow describe this design and say, is it good? Is it bad? What is it? And what he can say about the design. It looks okay. I think it looks okay. Or my gut feeling tells me, it's too complicated. I think it should be simpler. But what should be simpler? It's like you're like too many classes or too little classes, or something is wrong with it. Or I think it should be more elegant. Your code is not elegant enough. Or like small methods, small classes, this is a problem a lot of programmers have, that especially Guido, that it's hard to talk about abstract things. Design, it's not something concrete. It's some people say even something relative. It's hard to have meritorical discussion about design. So, or test coverage would be better. Yeah, you know, test coverage. Yeah? But what part of the software should we cover? Yeah, so how to evaluate design? How do you tell if some part of your software, some part of your code is good design or bad design? How can you tell a difference? It's really hard. It's really hard. So let's focus on it a little bit. What is it? It's not like some tricky question. It's just, yes, it's a mug. And now the tricky question. Is it a good mag or is it a bad mag? Yeah. Okay, it's empty, it's bad. Yeah, but what would well-paid consultant say? Yes, very good. He will say, or she would say, it depends. Depends on what? Oh, yeah. All of the answers that I heard, probably there were more answers from the back that I didn't, are right. Yeah? But all of them are different. Yeah. So yeah, it's actually there are two things that are important in evaluation of design of anything. Is it a physical thing like a mug? Is it a building like real building like real architects do, or is it a software design? First of all, to evaluate anything, we need to have a context in which this thing will be living, like, will be used. Something will do about it. Yeah. For example, this mug, it's pretty big mug for my 1.5-year-old son. This would be very bad mug. Yeah, bad architecture, bad design, because wrong material. He will like throw it on the floor and it will be smashed into pieces. Yeah. But for some, I don't know, adult man with all fingers, who is right-handed and likes coffee and the color is okay for him and it's affordable and so on, this will be a good Mac. So the same Mac, yeah, depending on the same cup, yeah, depending on the context, will be either good or bad. Yeah? And the same with our software. So this is one thing, yeah, the context. And the other thing is our precise description or precise discussion about attributes of this cup. Yeah? So I can define a context in which I will be using it, and then I have to precisely define what kind of temperature range will it handle. Yeah? What kind of material it will be made of, and what are the qualities of this material. Yeah? So we actually, to be able to discuss the design, to be able to evaluate our design, we have to define context, and we need to define the precise attribute, or we have to have a precise attribute description. Yeah? Those two things enable us to talk about design in more structured way. Yeah? Not like, we are a really young profession. Like enterprise software development is maybe 60 years, maybe 70. It depends on when you begin the start. Like comparing it with real building architecture or medicine or law or finances, where they have thousands of years of their profession. Yeah, we are really, really, really young. So it's absolutely natural that we do not yet have this kind of body of knowledge, and that if I would ask, I don't know, any of you, please define me a module. What is a module, or what is a component, or what is architecture? I would probably have, like, everybody will give me a different answer. All of them will be okay, and each one of it would be different. So it's natural that we don't have it yet. So I will share with you how I approach this stuff. So how I define context, and how I discuss the precise attribute description. And we will do this precise attribute description based on coupling, which is a pretty abstract thing. It's hard to talk about it, and we will try to see how we can do it more precise. Okay. So in any kind of design or any kind of object design, we can look at the context from three perspectives. There are things that are in architecture called like architecture drivers, which define the context of our system. This is a business context, project context, and or drivers and qualities or quality attributes of the software. So first, there is a business context. The goal, the vision, the requirements of the stakeholders, the problems we are trying to solve. So sometimes we call it functional requirements. We have to know who will be using the cup, how he will be using it, for what kind of beverage it will be used. All of those requirements are needed. The second part is the project part. How much money do we have for it? How much time we have for this particular project? Do we have to do in 1 week, or do we have 3 weeks, or 3 months, or 2 years, as with some government projects? Or what kind of available materials do we have? Or do we have experienced Ruby programmers or Java programmers? What kind of, I don't know, frameworks can we use? What kind of architectures do we know? What kind of patterns? What is our body of knowledge that we can actually use? Like in real building, what kind of materials do we have? With what we can build it? And available know-how. What is the knowledge of our people on this project? Everything is a context that we have. And the third thing is our quality attributes. What kind of quality attributes our project should expose? Availability, security, reliability, extensive, all those lities. Something and liti at the end, and there is a like wiki page with like 50 or 60 of them, so you can go and check. There is a lot of them. But this is the first thing that we need. When you are building a house or you're building some other structure, the first thing architects do, they look at what is around them. So they are looking at the space available, what kind of buildings are on the not the landscape, but how do we call this? So on the surrounding, the neighbors. What kind of buildings your neighbors have, or what are the some kind of rules from the government about how high the building can be here and so on. So this is what architect or designer starts with. They start with the context. Without the context, we cannot evaluate. We cannot say, is it good or bad? Because everything depends on this context. Everything depends on the surrounding. This surrounding is our point of entrance for any evaluation of any design of anything. Okay, great. So we have context. We've defined the context. We define each of those three things that we have. We now know what is the surrounding. And now the second part. And the second part was talking precisely about the design. But Guido still has a problem. How to talk precisely about abstract things? It's really, really difficult. So, is it really? How do we do it at nature? How do we do it in everyday life? For example, how do we talk about time? Time is a really abstract concept. Nobody sees it. Where is it? But everybody talks about time in a different manner. For some people, time is money. I'm spending my time on something. Or time as a container. I have to do it within some time. Or I can treat time as changer. Time will heal your wounds. We are using, to talk about abstract things, we are using metaphors with some real, tangible things that we have or that we interact with on our daily basis. It's really hard to talk about abstract things, but we, during thousands and thousands of years of our existence on Earth, we've learned how to do it. we are using metaphors to build some kind of intuition. Yeah? These are not one-to-one mappings. Yeah? Time is maybe not exactly money. Yeah? But it makes it easy for us because we know how we handle money. We know that money is precious. We know that we can spend it on this or this, and time has the same quality. Yeah? So we are trying to find similarities with our design, with our things in a real life. So now the question is, what kind of metaphor can we have for coupling as the example of one design quality or abstract quality that we have in code? What can it be? Yeah, and when you think about it, even object-oriented programming or thinking about programs as objects which communicate with messages, it's another metaphor for abstract thing. We know how objects work. We know how to send messages between them, and this is something our minds can work with. How our minds are handling the abstractness or the complexity of the problem that we are solving. So let's go a little bit deeper with this metaphor. I'm using because object is very general. I'm thinking about objects as people. That each object that I have is some kind of person which has a role. And the whole software or the whole program, it's like set of objects which communicate with each other like in company. There is a CTO and tells, okay, now we want to I want to have this project created, and this message goes to some team lead spreads this message to some programmers communicate with each other, and at the end we have the product ready. Yeah, objects communicating with each other using messages, and the result is there. Yeah? The same in military. There is a general gives order gets propagated among the graph of objects, which are soldiers, and at the end we have result. Very natural thing of a very natural way of thinking of it. So object not as a artificial like things like, I don't know, a remote, yeah, or sandwich or a cup, but as a living person which is naturally sending messages. Yeah? When we are talking to each other, we are sending messages. We are building sentences. There are only 3 kinds of sentences people can build. Yeah? I can ask you a question, I can give you an order, or I can inform you about something. Yeah? In any language, there is no other type of sentence in this particular context. Yeah? There are only questioning sentences, ordering sentences, or informing sentences. Yeah? That is why in programming or in object-oriented programming, we only have 3 kinds of messages. We have commands, queries, and events. Each one representing the one particular way how we communicate with each other. And there never will be more, there never will be less. Only those 3. Because it's not a programming thing, it's a linguistic thing. It's a communication thing. So this is the metaphor that we will be using. And using this metaphor, we will try to build a little bit of intuition about how we can think about coupling. Yeah? And this will be the dangerous part, because this will be the live coding part. And you know how live coding goes on conferences. Yeah. Most cases doesn't really work. Okay, so we will build. So we have the I don't know the nice word for up. So now everything should be okay. Okay, so we will build a company. This will be a small company, 1-person company. So who is what is the role of the person with 1 person? When you have 1-person company, what is the role of the only employee? How do you call it? The only employee in the 1-person company. Sole proprietor, okay, but more commonly boss, owner, yeah. But in most cases in Poland, this will be some kind of director, yeah, because there has to be some kind of esteem with the role, yeah. So there has to be a director. So let's have a director. So we will have a director. Ugly language, really ugly language. Oh, yeah, no. Okay, and the company also have to do something. So most of the companies in Poland are serving some kind of services. So we will have a method that will be doing like how we will call it. Do your job. Do your job. And the method do your job, since there is only one employee, director, do the job. And yeah, and this is really like modern IT company. So what the director needs to do his work. Modern IT company. What is the one object that he needs to? Yes, exactly. He needs a computer. So I will do it here. Computer, create a field computer, some kind of computer, create class. Oh, of course, rename. And we have a director and we have a computer and he will be doing his job. Great. But computers are mechanical things and they have a tendency to break, right? They break. So responsible programmer, like the fancy coding, will do if like computer is broken, then what? Yeah, no, somebody, we are not like in this throwaway culture, yeah, we are now in this like fix your stuff culture. Yeah, so so what do? Computer is broken, what do you have to do? Nothing. So we have to fix it somehow. If computer is broken, we have to fix it, yeah, else do something. Yeah, this is not interesting part for us, but things we have to fix it. Let's say we have to fix it. And if we have one person company, sole owner, yeah, who will have to fix it? Who will be the IT guy here? In one person company, who will be responsible? Exactly, the director will have the method fix computer. Great. And he will do something like this. Exactly. And now, this is the part that we want to start with. There is a coupling here. And the first thing is between what two things the coupling here is between what two functions, between what two people. There is a coupling between a director that wants to do the work and between the IT guy that will be fixing the computer. In this case, this is the strongest coupling that we can be when we have the relation is a, because the director is a IT guy. So this is the strongest kind of coupling. And now we will go here. And how can we talk about this coupling in more precise way? When you think about other people, objects as other people, there are actually 4 basic qualities that we can have describing the relation between them, the relation in, say, space and behavior. We can know how something can be done. We can know where is this person that will be doing it. We have to know who is this person who will be doing it, and what will be done. Only those four coupling, only those four qualities. And the first level of coupling, the highest coupling, is something that we can call local method. When I am a director, I know everything about the other thing. Yeah? I know how to fix a computer. I know where the computer will be fixed because I will be fixing it. Yeah? I know who will be fixing it because I will be fixing it. And I know what will be done because the computer will be fixed. This is the what, yeah? Fix the computer. The how, implementation of the method. The who, the me, the where in my instance. Yeah? The highest form of coupling of two objects when one object is another object. And in practice, it's just a private local method. It doesn't have to be private, yeah? But it's the local method. First level of coupling. Okay, but now our company grew a little bit. We have our computer is broken a lot more often than we thought at the beginning. Yeah, so what we have to do, we will hire somebody. We will hire John. We will hire John. John, the IT guy. John, the IT guy. John, the IT guy. Yeah. IntelliJ. Great. John, the IT guy. Great. And now we will decrease the coupling between the fixing of the computer and the director. We will move the method to another instance. To the instance, Joe, the IT guy, please fix the computer. What we actually did, we decreased the coupling. How does it look on our diagram? We now don't know how is it done. We know where it will be done because we know the instance of John. We are creating it, so we know where he is. If we are using new or we are creating the object by ourselves, this is like a relation in space. We know where it is. We know he is here. It's like I will come directly to John. I know where he sits. He sits at this desk. I will come. I will give him a computer. I will say fix it. But the only thing I don't know is I don't know how it will be done. Because how it will be done, now it's the knowledge of John, not me. So this is another level of coupling, which is called local instance coupling. And we can decrease it even more. John, he's really tired of being at our office. He wants to, work remotely. He would say, Mr. Director, we are a really modern company and I don't really need to be here because I can remotely log in to your computer and fix it and remove, all your browsing history and so on to Yeah, so I don't really have to be here. Maybe it is possible maybe it is possible for me to work remotely. And we say, okay, on this market it's really hard to find a new IT guy, so we will let him work remotely. Yeah, so how this remote will work? Okay, so we will make it. So we will make it private final. We'll delete this, and we will add a constructor. Great. And we once again decreased coupling. How does the coupling decreased? How does the coupling decreased right now? Okay, so let's look at our table. Now we have the level that we can call external instance. We don't know how. We don't know how John will do it. We don't know where is John. Yeah, it's like we can only call him, so we have his number, we have his reference. The reference is like a phone number, and John is somewhere there, maybe on some island, yeah, maybe at his home or whatever. We don't know where he is. We have only his reference, but we know who he is. This is John. Yeah, we don't have a number to some many particular. We have number to the particular person John, and what he will be doing, he will fix the computer. So coupling is a little bit less. Okay, but our company right now is like very successful company. The services that we are providing, they are really high level, and everybody is appreciating them, and we have a lot of customers, and we became a really big company, and one IT guy is not enough. We need to have something more. We need to have IT service, or IT department. We need to have IT department. So we will not know directly that will John. Yeah, John is not something we interact with anymore. We will interact with IT department. IT department. Okay. This will be here. Create. No, not a class. It will be not a class. It will be an interface. IT department. We will add the constructor. And here will be the IT department, and IT department will have a method fix. Great. And what we did now? We decreased coupling a little more. How does it look on our table? We've actually are on the level which I call configurable instance, because everybody will say, yeah, Łukasz, you are just doing dependency injection and calling it fancy like configurable instance, yeah. But when you think about it, what is dependency injection? Yeah? What does it really mean, dependency injection? If you will tell to somebody that is not technical, maybe to your kid, maybe to your wife or your spouse or whatever, he would say, what were you doing today at work? Well, you know, I was like injecting the dependencies, and it was really hard to figure it out what I should inject and what I should not inject. And now, what is in the head of this person? Yeah, they are like having some kind of needles maybe, and you know those how it's called, yeah, syringe, yeah, and there's some kind of syringe that they are injecting those things inside. I always wanted to know what is inside those computer, and there are syringes there. It's really great, yeah. It's really sucky metaphor, yeah. And what we actually achieving with dependency injection with interface, because the previous one we could also call dependency injection with instance, and now we can call it dependency injection with interface. But this exactly what we have is just configurability. I can configure the director with different kind of IT departments. Yeah, this is configurable instance. It's like a bicycle. Yeah, bicycle is a perfect example of dependency injection. Only if we will call it configurable instances. Every part of the bicycle except the main the frame, yeah. Everything except the frame is configurable. I can have different instances of steering wheels. Yeah, I can have different instances or different implementation of wheels, because there is this kind of coupling between the frame and the handles, and between the frame and the wheels, that enable them to be configured. This is a really complicated stuff. It would be much easier if it would be just like fixed, like the one part, the frame and the steering wheel will be only one thing. It will be cheaper to do, everything will be better. Yeah? But we need this kind of configurability, so we pay a price for it. Yeah, we make it a little bit complicated, yeah, because when we were fixing it by ourselves, it was really cool. Yeah, but configurability is something that we really like. And how can we think about this configurability? We can think of it as we are not calling the person directly, so we are not calling John, but we are calling some kind of call center. We don't know exactly who will we call. Yeah, we'll just call some kind of dispatch. Object-oriented dispatch, yeah, there is a dispatch there, and the dispatch will dispatch us to some particular implementation of the IT guy, yeah, because you know John can be sick, he can be not at work, we can have No John exception in the previous example. Yeah, this is really bad exception. No John exception. We cannot fix this. Yeah? And this in particular way, we are handling the no John exception in really, really good way, right? Yeah, just because we make it configurable. Yeah? This is configurability. And now we can ask the question, do we need this kind of code to be configurable? Yeah? And ask another question, do we need this part of code to be dependency injectable? Shit, doesn't really make sense. Yeah. Or maybe only for me, because I'm not native English speaker, because maybe for native English speaker it makes sense to make something dependency injectable. Yeah, doesn't really. Yeah, okay. So this is the basic, the most common level of coupling between two people that we encounter in our software. But we can make it even less. We can make it even, let's say, not less, but weaker coupling. Instead of because our company, let's say, our company is now really, really big. We are corporation. And in the corporation, does the director really goes to IT department and say, hey, can you fix my computer? No, right? What does the director in the big corporation do when this computer is broken? Who does he call? Yeah, he's calling an assistant. So instead of injecting here the IT department, we will inject here assistant. I will remove it here. Assistant. Hopefully I didn't make, and this is also an interface. And rename it assistant. Oh, no, yeah, now it will be much better. Thank you, IntelliJ, for code completion and fixing my end. And now, really nice things happen, because we will not say what to do. We will now say to the assistant, no, assistant, fix my computer. I don't know, maybe it needs fixing. Maybe it needs replacement. Yeah, maybe it just needs, I don't know, charging or whatever. Yeah, you know, I'm just a CTO or CEO. What can I know about computers? I just know about money. And computers make money, so I'm in computers right now. Yeah? So I will not tell them imperatively what to do. Yeah? I will tell them declaratively what happened. I will say, my computer is broken. Do something about it. And maybe I will not me, but my computer is broken. Or no. I will say to my assistant, because this is generic assistant, and an assistants can handle a lot of different messages. So I will make a method handle, and I will create a class that will be representing my action, which will be called an event. And now my assistant can handle that my computer is broken. And let's look at our table, because the last level of coupling is notification. I don't know how it will be done, the fixing of my computer. I don't know where it will be done. I don't know who will do it, and I don't know what will happen. Maybe it will be fixed, maybe it will be charged, maybe it will be replaced. I don't know. And the question is, yeah, do I have to say what should be done? Should I have to be imperative man, or should I be just saying, this happened, handle it? Because I don't want to be coupled with you in that manner that I will always tell you what to do. I don't want to always tell you what to do. Sometimes I would just want to, like, tell you this happened, just do it. Yeah? And those are five basic levels of coupling that we can now like recognize in our code. Yeah? We can talk about it, and we can relate to them in this kind of metaphor. It don't have to be that everybody talks a bit about different, and everybody has this intuition about coupling, yeah, or this instinct it's hard, it's tight, it's loose. Yeah? And the next thing is that coupling. Yeah, coupling. The tight. We know now what are the levels of coupling and so on, and which kind of level of coupling is better: the high coupling or loose coupling, which is better, which is more preferred in the design. Very good. We have a potential for new consultants. Yeah, please come to me after the talk. And exactly, it depends. Yeah, coupling is just like gravity. It isn't like bad or good. It's just some kind of force. Sometimes it's good, sometimes it's bad. Sometimes we want to have high coupling when we are in DDD context within the aggregate. Yes, and we want to have those invariants protected and so on, then we need high coupling. But between services in microservice architecture, yeah, we want those services to be as much independent as they can be. So there we will want to use the technique that makes this coupling as loose as possible. So it will always depend on the concrete place or concrete usage about it. But what is the lesson at the end of this talk? To have better design, you have to first learn to describe the design precisely. It's really hard to keep your team in sync. It's really hard to communicate about the design because design or things are really, really abstract. Yeah. So first you have to learn about it. Then you have to learn how to talk about it. And it's not really only coupling. Yeah, these are coupling, this is architecture, these are all the other kinds or elements of design that are useful for us, or different kinds of abstraction that we are using. Yeah. So first learn to talk about it, and then the design will come. Yeah. So yeah, don't do it instinctively like Guido did it. Okay, so thank you very much. Hopefully I didn't. No, I think I have a perfect time, 45 minutes. So there is of course no time for questions right now, but maybe, I don't know, one or two. I don't know, if there are some questions, then I'm happy to answer. If not, I will be for some time here so you can catch me up. And okay, there is one question.
How to massively detect coupling. So if you have a big project that you join and you want to know about bad couplings, how would you like start working on this?
I will start working on this. Let's say very context specific questions, and the theoretical answer will be metrics. Yeah, there are metrics for coupling, let's say, but from my experience, this is only theoretical answer because on the new project, massive project, that has problems with coupling, those metrics, or there's so much of it, yeah, that this is not really those metrics don't really say nothing, because all of the code is coupled in such a way that, okay, I can like see that everything is coupled with everything. The number will not help me. Yeah, this is more of the communication tool and educational tool that will enable those people that did this project and now want to do it better to start like talking about it in a precise manner, so that they will not end up with the same bad code or bad design again. Yeah? So I will say rather not. Yeah, it's not something that you can apply after. It's just something that you have to apply before, because design needs to be first. Yeah? Design first and not design at the end. Yeah? But maybe there are some tools that can help. I'm not aware of them. Yeah? For me, the educational part of it is the most important, the communication.
Okay, thank you.
There is one
Yes.
person there,
Sorry.
so maybe let's say last question. And
thank you for this possibility. You said in the very end of your presentation, don't do that into like intuitivity into it. Yeah.
Yeah, instinctively,
like,
intuitively.
yeah.
Yeah.
So, don't you think that for people with large experience and not an intuition like intuitivity, but just experience, and sometimes like experienced architect can even correct probably the customer requirements on business, on quality, on whatever. So if we have like a very beginner level customer who don't know exactly what don't know or has some feeling, believing that he can hit the market with that and that, but the experienced architect just with his or her intuition can correct even those design quality requirements. Is it work also?
Yes, I'm a maybe not big believer, but let's say, yeah, I'm a big believer in something that is called tacit knowledge. So this is this kind of knowledge that cannot be expressed with words. Yeah, so there is this psychological, philosophical, saying, let's say, that we cannot say everything we think within, because there are some tacit knowledge that cannot be expressed, and the intuition is something in experienced person that is really good. But the problem that we are solving here is the cooperation problem, because I'm totally agree with you that experienced architect can do great design. But what we are solving here is the communication of the design, and then also mentoring of the other people, so that we can like understand why the design is the way it is, why I picked this kind of thing and not this kind of thing, and to be able to evaluate it together. Yeah. So once again, communication. And not one person doing the right thing and then telling all the other people how they should do it without explaining it, not because not because it's a bad idea and he don't want to, but because he just doesn't have the vocabulary or metaphor to tell the younger people, the younger programmers, why exactly this is this way, why exactly this is that way, and also giving feedback to the people that he works with. Okay, you created this design, yeah, and can you this is this kind of level, and then use that because here I need configurability, and here I have a tight coupling because I need consistency, and here I have like loose coupling because I need eventually consistent system, and so on. Because there are like consequences to the level of coupling in the field of like architecture of the whole system. Yeah, this is one of the basic thing that we need to think about, and they were building on it some more. So it's more precise communication, precise description, and it doesn't exclude the intuition of the experienced architect that has this gut feelings. I also have those sometimes. Yeah, like I know it will be a bad idea, but I cannot tell you why. You just have to trust me. Yeah, and this is absolutely for me okay and absolutely acceptable. Yeah, this body of knowledge that we acquire during our lifetime. Yeah. Okay, so thank you very much. Thank you for your patience. Thank you for coming here this early on Sunday on this weather. It's really, really cold. Yeah, so thank you very much, and hope you've learned something today.